expressions and equations number 8. We're still analyzing systems of equations, but in part 2 of Learning Target 2, we're going to get the privilege of learning the elimination method. So to define the elimination method, it's a way to solve a linear equation system algebraically, and we use it by eliminating one of the variables and then solving for the other variable. So if you eliminate the x variable, you're going to solve for the y variable first. Or if you eliminate the y variable, then you'll solve for the x variable first. And there's 4 steps to using the elimination method. First, you're going to write the systems that the like terms are aligned. That means the x's over the x's, the y's are over the y's, and the constants over the constant. You're going to eliminate one of the variables, and I'll teach you how to do that. And then you're going to solve for the other variable. And then you're going to substitute what you solve for. So if you solve for x, you're going to substitute that x in for one of the equations and solve for y. And then, of course, you're going to write it as an ordered pair, and we're going to check it. So we'll get started here with our first example. So here's our system of equations. Okay, you're going to notice a little bit difference. They're kind of written with the x and y on the same side because that helps us set up for the elimination method. I'm just going to rewrite it so I have a little room to work here. So when deciding which x or which variable to eliminate, it's totally up to you. Mathematically, it does not matter. You just got to decide how you want to eliminate. So when I look at this, I can choose to eliminate the x or y, and the way you're going to figure that out is you have to have the coefficients in front of the x or the y opposites. So for example, since this is 8, I would have to make this one a -8. Or because this is a -8, then I'd have to make this one a 6. Well, you can't just change it a 6. You actually have to multiply the whole equation times a number to get there. So I'm going to eliminate the x on this first one. So again, I want this to be 8. So when I add the two x values together, they're going to cancel each other out. So that means I have to multiply this whole first equation by 4, again, to eliminate the x's. So I'm going to take 4 times -2, which is -8x. I'm going to take 4 times 2y, which is 8y. And I'm going to take 4 times -2, which is -8. And then I'm going to add that, and you always add it to the equation I didn't change, because now I can work with this since they have opposite coefficients. So if you look right here, what's going to happen if I take -8x and I add an x, 8x, that is going to eliminate each other out, which means all I have left to solve is the y. So I'm just going to treat it like an addition problem. 8y plus -6y gives me 2y's, and -8 plus a -12 gives me -20. So again, notice that I keep adding is my operation. And now I'm going to go ahead and solve. So I'm going to divide by 2 on both sides, because if 2y equals -20, that means 1y equals -10. So I'm going to start my ordered pair over here. So from what I figured out, y is -10. Now to go find the x value, you're going to substitute that -10 in for either one of those equations. It really mathematically doesn't matter. It's just kind of how you want to do it. I'll just put it in for the first one. And the first original one, I want to make sure that's clear, not the one that I changed. You want to go back to your original 2 equations. I'm going to go back to that one. So this time I'm going to plug -10 in for y. So -2x plus 2 times -10 equals -2. So -2x minus 20, because 2 times -10 is -20, equals -2. And so then I'm just going to solve it like a 2-step equation. I'm going to add 20 to both sides. I get -2x's equals 18. I'm going to divide by -2. And I get x to be a -9. So now I can put -9 here. So I've written it as an ordered pair. Last thing to do is to check. So as I check, I'm going to plug them into both. So -2 times -9 plus 2 times -10 better equal -2. Well, this is 18. This is a negative 20. If I take 18 minus 20, that does give me negative 2. So I know it's correct for the first equation. Always have to check both when you're doing a system. So we're going to take 8 times negative 9 minus 6 times negative 10. It better equal negative 12. So I have negative 72 plus 60. Well, if I take negative 72 plus 60, that does equal a negative 12. So I know I'm correct. Okay, let's look at another example of the elimination method. Okay, so there's my system. This time I'm going to eliminate the y's just to see it differently. So since I have a negative 2y and a 6y, it'd be easiest to make them negative 6 and 6. So what I really do is look at the top number, and I try to figure out if I could take the lower number and multiply it by something to get to the other coefficient. In this case, I can make this a negative 6, which means I'm going to take this whole top one times 3. I'm going to write that out here. And I'm going to go ahead and multiply times 3. So 3 times 5x is negative 5x. 3 times negative 2y is a negative 6y. 3 times negative 15 is a negative 45. I don't have to do anything to the second equation since I have my coefficients opposite already. So I'm going to pull that all the way over here. So I get 9x plus 6y is equal to 3. Go ahead and remember the operation is addition. So I'm going to take negative 15x plus 9x, and that gives me a negative 6x's. Good news, these canceled out, or as we know it, eliminated out. And then negative 45 plus 3 is a negative 42. I'm going to divide by negative 6 to get what 1x equals, which is 7. So one of the answers, or the x value of the answer, is 7. Now I'm going to go ahead and plug it into, remember I said one of the originals, this time I'll plug it into the bottom one. So 9 times, instead of x, I'm going to put 7, since that's what I just mathematically found. I'm going to add the 6y, and it equals 3. So 9 times 7 is 63, add 6y equals 3. Subtract 63 from both sides. I get 6y is equal to, that is a negative 60. Because 3 plus, I'm going to put my addition sign here, 3 plus a negative 63 would be negative 60. Divide by 6, and y equals a negative 10. So if I'm right here, as we check, it should work. So we're going to check. Here's my check. Take that top one. Remember, go back to the original always when you're checking. So negative 5x minus 2y equals negative 15. I'm going to plug in my value. So negative 5 times 7 minus 2 times negative 10 equals negative 15. This is negative 35 when you multiply. This is a positive 20. Negative 35 plus 20 does equal negative 15. So it works in the first equation. Have to try it in the second one. I'm going to try it in the second one here of the originals. So 9 times 7 plus 6 times negative 10 has to equal 3. So 9 times 7 is 63. 6 times negative 10 is a negative 60. 63 minus 60 does equal 3. So I can guarantee you that the answer of 7 and negative 10 is correct. So that's the one solution, is where the two lines would have graphed and intersected. Next example, so I'm going to go over that first step. If you go back there, you have to line up the terms. So what that just means is, notice that the x's are lined up and the y's are lined up and the constants are lined up. If they're not lined up underneath each other, then you can't do this. So you have to set them up. It's kind of like when you did addition vertically. You're going to set everything up correctly to a place value. Same thing here. You're going to set everything up correctly to the variable. So these are x's, then we have y's, and then we have constants. Okay, this time I'm going to look at it. I get rid of the 6, we'll go back to getting rid of the x here. So if I want this to become a -6, remember I want them opposite coefficients, I'm going to have to take this top one times a -2. I'm going to go ahead and do that. And I'm going to get -2 times 3x is -6x, -2 times 2y is -4y, and -2 times 6 is -12. And that can happen because it's still equivalent as long as you multiply every term by that -2. I'm going to pull the other one over. So 6x plus 4y equals 12. Okay, I'm going to add them up. I'm going to look at this and say, -6 plus 6x leaves me with no x's. -4y plus +4y also leaves me with no y's. So I'm left with nothing on my left side. I'm going to look at my right side. I'm going to notice, well, -12 plus 12 is also 0. So since 0 equals 0 is a true statement, then I can tell you that the answer is infinite solutions, because you canceled out the variables, which leaves you with the mathematical statement of 0 equals 0. Again, that's true, so it's infinite solutions. And our last example for today, and we're going to start with this lovely system of equations. I'm going to check it out here. Let's get rid of the y's this time. So let's take this, since this is 4y's, let's take it times a -4y's to get that top one. So we're going to take it times -4 times -3x plus y equals 1. And that turns into 12x minus 4y equals -4. Again, I'm just distributing. So I multiplied -4 times -3x, -4 times a y, and -4 times 1. And then I'm going to pull over the equation I haven't touched. So this is a -12x. This is a -4y. And this is a 3. Oops, sorry, that's a positive. I didn't pull it over right. So it's a -12x, a positive y, and a positive 3. I'm going to go ahead and add. And I notice, again, that the 12x plus a -12x cancels out the x's, so they're gone. -4y plus y, 4y, again, cancels out. So I end up with nothing again on my left side. I'm going to look at my right side. Well, -4 plus 3 is a -1. Well, this statement's not true. 0 does not equal -1. So since that's an untrue statement, that means my solution is no solutions.